Our next part deals with the volumes of prisms and cylinders. Now, volume is related to these units of capacity. The volume is the amount of space occupied by an object, although here we're going to measure in cubic units. Although technically those units above were volume or capacity, for this chapter and for actually evaluating or calculating volume, we use cubic units such as meters cubed, centimeters cubed, maybe feet cubed. Those will be the units on volume. In general, the volume of an object is given by the area of its base multiplied by its height. That gives us the amount of space inside the object. An object's height is measured perpendicular to its base. So if the base is flat on the ground, we will multiply it by its height, which is straight up vertically. Examples. Identify the base of each object and calculate its area. Then use the base area and height to calculate the volume of the object. And here, if you can see our first example A, we have a triangular prism. First, let's find the area of the base. Now, the base of this is the triangle shape itself. I know it's the way it's drawn, it's vertical, but the base of the prism is the shape that's extended from one end to the other. Or looking at what this is called triangular based prism, we can see that a triangle is the base. So our first step is going to be to find the area of this triangle face right here. Then once we have the area of that triangle base, we can multiply it by the height of the prism to find our volume. So first, looking at the area of the base. The area of the base of a triangle, well, the formula for area of a triangle is from before base times height divided by 2, or 1/2 times base times height. The base, and this is now the base of the triangle face we're talking about, the base is 5.1 feet. The height is 1.0 feet. So this triangle, now the terminology is a little confusing because right now I'm talking base and height, but just of the triangle face. The other height that's written here, that's the height of the whole thing. So it is a little bit confusing. I have two H's. One's talking about the height of this triangle. One's talking about the quote-unquote height of the prism. For that, I'll use a capital H rather than the lowercase h. But anyway, the base times height divided by 2 to give the area of the triangle is 5.1 times 1 divided by 2. And 5.1 times 1 divided by 2, we can write in our brackets here. That will be multiplied by the height of the entire prism, which is 4 feet, 4.0 feet. Okay, that last step, the area of the base multiplied by the height itself, 5.1 divided by 2, times 4 gives me a final answer of 10.2, and my units on this are going to be cubic feet, or feet cubed. 10.2 cubic feet. That's my final answer. Now, interesting note, for this shape, they gave us actually extra information that we didn't have to use. This 2.4 feet, this edge of the triangle, did we have to use that? No, actually. And the 3.1 feet, the length of the other side of the triangle, we didn't have to use that either. So all we needed to find was the area of the triangle, using the 5.1 to 1, and then after finding the area, multiply it by the height, which is the 4. That's it for volume of a triangular based prism. Secondly, volume of a cylinder. So a cylinder has a circular base and a height. In this case, my diagram shows the circle has a radius of 2.5 centimeters. That will be used to find the area of the circle, and then multiplying by the height will be multiplying by 9.6 centimeters. So my very first line looks the same. Volume is equal to a general area of the base in Example A is a triangle. Here in example B, it's a circle base, and then multiplied by the height. So first, what is the area of the circle itself? Well, the formula for area of a circle is pi times r squared. R, the radius is given, it's 2.5. So pi times r squared will be pi 3.14, or using your calculator button to make it more accurate, times 2.5 but squared first. So if you'd like, you can do that first bracket first just to get an idea. 2.5 squared, if you do that on a calculator, it's not shown here, but it comes out to be 6.25. And then multiply by pi in your calculator is equal to 19.63 something. Multiply then by the height though, and multiplying by the height of 9.6 will bring us to the volume that we need. Doing that should come out to be a final answer of 188.4955592 in my calculator screen. And that can be rounded to 188.5. Now the units were centimeters in the diagram. This is volume now, so my unit on volume is centimeters cubed, or cubic centimeters. Okay, next we have the surface area of prisms and cylinders. So the volume was the amount of space inside. The surface area is the total area of the surface of an object. For the surface area, we'll find the area of each side and then add them together. Example A. Describe the faces of each object to determine the surface area. We have a rectangular prism. So we have three different faces here. I have lengths of 10 inches, 4 inches, and 7 inches. Each one has two faces. There's 6 faces in total: the front and back, the top and bottom, and the left and right hand side. So the first face, let's look at the bottom, the base, the 10-inch by 4-inch rectangle, which is the bottom of this rectangle, and also the same dimensions as the very top of it. So there are two faces with those dimensions. The area of each of those is just length times width, 10 times 4, which is 40 inches. But there's two of them, so there's 40 inches squared on the bottom, and another 40 inches squared on the top for those two areas. So altogether that adds up to 40 plus 40 is 80 inches squared. Let's look at two other identical faces. Next, the 4-inch by 7-inch rectangle. That's the rectangle on the right hand side, straight up, and on the left hand side going straight up as well. So there's two of those identical faces. There's two 4 by 7-inch faces. The area of each of those is, again, length times width. 4 times 7 is 28 inches squared. And there's two of them, so 28 times 2 is 56 inches squared. So there's 28 square inches here, another 28 square inches here. Those two faces contribute to 56 inches squared altogether. The last face is the 10 by 7 rectangle. This is the one facing us in the front, and as well as the one in the back of the shape. So the two faces each have an area of 10 times 7, which is 70 inches, and there's two of them. 70 times 2 is 140 inches squared. So altogether, we have the 80 inches squared from the top and bottom, the 56 inches squared from the left and right hand faces, and the 140 from the front and back faces. Our final step to find surface area is to add all of those together. And doing so gives me my surface area, my total area of 276 inches squared. It is area, so the units will still be squared. And that's it for rectangular surface area. Now, in example B, cylindrical surface area is a little tougher. We have to find the area of each face. Now this we could consider to have three faces: the flat circle on the top, the flat circle on the base, and then the curved rolled the rest of the cylinder itself. Now if we unrolled this, if you could picture this coming apart like the label on a can, unrolling it and flattening it out would make this look like a rectangle. So this is, we could describe it as a rolled, or if we unrolled it, a rectangle. Let's start though with the faces of the circles on the top and the base. The area of a circle is pi times r squared, and again we have this radius of 2.5 centimeters. So as before, my area of the top circle will do pi r squared. 2.5 squared times pi gives me an area of 19.635, and that would be in centimeters squared. There's two of those though. If I multiply by 2, because one for the top and one for the bottom, I get an area of those two circles of 39.270 centimeters squared. Now, the vertical area of this unrolled rectangle can be found by multiplying the height by what would be the length of this rectangle if it was unrolled. But that length around in its current rolled state is actually the same as the circumference of the circle. So this rectangle, length times width, the length we could consider to be what that circumference around the circle is, because that's kind of how long the stretch of rolled material is. The formula for circumference is 2 times pi times r, which in this case is 2 times pi multiplied by 2.5. Doing that and then multiplying by the width, which in this case in the diagram is what looks like the height, the 9.6 centimeters, is altogether 150.796 centimeters squared. It's a little hard to visualize, but picture unrolling this cylinder. The length would be what is now the circumference, 2 pi r. The height, or width if you will, is 9.6. Multiplying all that together gives me this 150.796. Finally, my two areas altogether added up, the two circles in one and the unrolled rectangle. Adding these up gives me an overall area, a surface area of 190.1 centimeters squared. So that's the final chapter for this Intro to Geometry. I know it covers a lot of different chapters. Give the practice questions in each chapter a try. And as always, below we have textbook answers and full solutions. Good luck.